Hey, it's Eric Roth from EDD Academy, and we are going to be going over MIT Integration B Problem 4 of the 2019 qualifying exam. So, what you see on the screen is the integral as it was presented in the exam, which is the integral from negative 1/2 to 1/2 of dx over 1 minus x squared. So, I see a couple things right off the bat, and one is that you'll notice that it is an even function, and the bounds are symmetrical about the y-axis, which means we can simplify it like this. 2 times the integral from 0 to 1/2 of 1 over 1 minus x squared dx. And this is because of the properties of even functions. So from here, I don't see any obvious antiderivative of 1 over 1 minus x squared. If we had 1 over 1 plus x squared, we could use arctan, but that's too nice to be on an MIT Integration B. So what we're actually going to do is we're going to do trig sub. And in this case, we're going to trig sub sine theta, because 1 minus sine squared theta is cosine squared theta, which makes it a lot simpler. So say just like this. And then we're just going to be doing the substitution. So 2 times the integral from, and here's where you want to replace the bounds, because remember with trig sub, we really need to replace the bounds. So when x equals 0, right here, we need to figure out what sine theta is, or actually specifically what theta is. And we know that sine of 0 is 0, so theta is just 0. And then when x equals 1/2, what is theta? Well, first we take arcsine of 1/2, which if you remember your trig table is just pi over 6. Just like this. And then we can just take 1 over 1 minus sine squared theta, just directly replacing the x into the x squared. And then dx, we can just say is cos theta d theta. And now we pretty much have everything we need. We just need to simplify, and then we'll be done. So I'm just going to put a little line to separate. So 2 times the integral from 0 to pi over 6. Notice that this is just 1 over cosine squared theta, cosine theta d theta. Cancel out the cosine, cancel out one of the cosines in the bottom, and we're left with 1 over cosine theta, which we know is secant theta. So our integral, which we know we can evaluate now, is 2 times the integral from 0 to pi over 6 secant theta d theta. And here's where you just need to remember your integral tables just to do this pretty easily. So we just get 2 on the outside because it's a constant, and then ln of, oops, that should be an absolute value sign, ln of secant theta plus tan theta on the bounds 0 to pi over 6. So now all we got to do is just plug in, we should get our answer. So 2 on the outside still, ln of secant of pi over 6 is 1 over cosine of pi over 6. And we know that cosine of pi over 6 is root 3 over 2. So the reciprocal of that is 2 over root 3. And then we need to add to what tan theta is. And tan theta is defined by sine pi over 6 over cosine pi over 6, which is 1/2 over root 3 over 2, which we can simplify as 1 over root 3. And then we want to subtract, and then we need to figure out what secant of 0 is. And if you remember, cosine of 0 is 1, so the reciprocal of that is just 1. So simply just get 1. And then tan 0, we just know is tan, which is just 0. So there. And first, what I want to notice is that this is all equal to ln of 1, which is equal to 0. So we can just cross that part out. And then the next thing is that what is inside this ln, actually, what is inside this ln simplifies to root 3. You can just check the algebra for yourselves. And so the final answer is 2 ln of root 3. And using the ln properties, we can actually put the 2 into the ln of root 3. So we actually get ln of 3 as our final answer. And this is what we're going to box out.